Hello and welcome students. This is a lecture on determinants. In last lecture, I have taught you properties of determinant and we have completed 6 properties on determinant. The last property that we have is, see the 7th property, property number 7. It is you can say this property is the easiest of all. And see what is this property. It says if all the elements of a particular row, if all the elements of a particular row or a column, if all the elements of a particular row or a column of a determinant are zeros, then the value of that determinant, will be 0. Very important property. Now see, so for example, if you go by example, what you will write, see, I write a determinant, and in that determinant, what I do is all the elements of a particular row, any row, so are 0. So say if all the elements of R1 are 0, so 0, 0, 0, 2, 3, 5, 3, 1, 9. You don't have to expand this, no need to evaluate it. It is 0. It is 0. Why? Because all the elements of R1 are 0. So the value of this is 0. Okay. For that matter, remember that here I have all the elements of R1 0. If this had been R2, you still could have written 0. If it was R3, all the elements 0, still it is 0. Okay. And even for the column, say if I have all the elements of a particular column 0. Say for example, if I have here the first column is say 3, -1, 9. The second column is 2, 3, 5. And the third column is 0, 0, 0. Now this time what's happening? It's all the elements of one column. Which column? Column 3 are 0. So the value of this determinant is also 0. Okay. This is example number 2. Please, you can copy this. So here we have one question on expansion. One question on evaluating a determinant without expansion. So the question is, without expanding, evaluate the following determinants. This is a question number 1 from exercise 4.2. Now see students, what I have to do is I have to evaluate the value of the determinant, but I am not allowed to expand it. You know the meaning of expansion of a determinant. It is applying the formula. We can, as you all know, that I can apply the formula along the first row. I can expand it along the first row. Okay. You can expand it along second row, along third row, or you can expand it along the first column. You can expand it along the first column or second column or third column. But they are saying don't do that. And find the value. We are not allowed to expand it, but we have to find the value. What does that mean? It means we have to use the properties. How many properties we learned? 7 properties. Okay, let's begin. See here. Students, I write let D equals to, that is value of this. I'm writing it as capital D. Capital D is the value of this. See here. What am I doing? The first property The property that I'm going to use here in the first step is as follows. See, I'm writing R3 changes to, I am planning to change R3. R3 changes to, I'm sorry, it is not R3, it is C3. C3 changes to, I'm planning to change C3, column 3. C3 changes to C3 plus C2. C3 changes to C3 plus C2. Okay. See students, I observed something which I want to share with you. See, what did I observe? I observed that in the first row, I observed that here I have A, but here I don't have A. I have B plus C. So if this is A, here B plus C. Then I observed that here I have B and this is C plus A. B, C plus A. This is C, so I don't have here C and I have A plus B. So such a pattern which I obtained some pattern in these elements and I'm going to make use of it. You know what? I'm planning to add all these elements in all the elements of column 2 in column 3. Okay, corresponding. So, and you know that is allowed. That is allowed. You know, I'm adding the column 2 elements with corresponding column 3 elements. Okay, that is allowed. So I'm writing C3 changes to C3 plus C2. Now, when you bring this change, what will happen? You can check. See, are the elements of C1 going to change? No, C1 are not changing. So 1, 1, 1. Are the elements of C2 changing? No, A, B, C. They will remain A, B, and C. A, B, C. And will the elements of C3 change? Definitely yes. The C3 elements are going to change. How are they going to change? See, the elements of C3 will change as C3 plus C2. That is, the elements of C2 we are going to add in C3. Okay, so just add it here. So it is already B plus C. When you add A, it will become A plus B plus C. This will, when you add this B here, it will become A plus B plus C. And this also, see here, you got A plus B, you add C here, it will become A plus B plus C. So what do you understand? You understand that you have A plus B plus C, the common element in C3. So this is after using one property. And the property says that when we do any such thing, that is, see, what is the property? Do you remember the statement? The statement was when all the elements of a particular column, when all the elements of a particular column or a row are added with the same multiple of corresponding element of any other column or row, the value does not change. So the value will remain same. What does that mean? It means that this is also D. This is also D. Now I go to the next property. See, the next property I'll be using is, I write here, see, I take A plus B plus C. What I notice, all the elements of column 3 are same. So I can take A plus B plus C common. Yes. And if I take A plus B plus C common, what will I get? See, I will get here 1, 1, 1. This is A, B, C, and here also 1, 1, 1. This is D. Okay, what I did, same thing, same determinant, but only A plus B plus C, which was common in column 3 elements, I took it out. I took that out. Now what? See, you can check. The next is, you notice that column 1 elements and column 3 elements are identical. So this is also a property. What? If all the elements of a particular row or a column are identical, the value of that determinant is 0. So value of this determinant is 0. So you have, finally, you will have therefore D equals to A plus B plus C multiplied to 0, and the value is 0. Here you will write, okay, C1 and C3 are identical. They are identical. The next question is, once again, we are given a determinant and we have to get the value of, we have to evaluate this determinant, but we are not supposed to expand it. Without expanding, do not expand it, get the value of this determinant. Okay, so how do I begin? I will write this as D. This is my, I'll write here, let this determinant be D, and now I solve this. Students, I will see, I notice that in the elements of R3, I have X common. Okay, so can I take X out? Yes. So I take X out, and when I do that, I get 2, 3, 4, 5, 6, 8, and 6, 9, 12. Okay. I still have something common in R3. And what is that? I have 3 common in the elements of R3. In each element of R3, I have 3 common. See, this is 3 into 2, this is 3 into 3, and this is 3 into 4. I can take 3 also common. I can take 3 common also, right? So what I will do is, instead of x, I take 3x common. What do I take common? I take 3x common. So see, student, from 6x, when 3x is out, what is the factor left? 2. From 9x, when 3x is out. See, when x is out, you get 9. When 3x is out, you get 3. And from here, you get 4. Gayatri, next step bolo.
Sir,
Here I will write, see, let me first write the reason. The reason I write is taking 3x as a common factor from R3, a common factor from R3. Okay. Now I write, therefore D equals to 3x into 0. Why 0? The value of this is 0 because R1 and R3 are identical. They are identical. Final answer is 0. 3x into 0 is equal to 0. See, students, in this question, what I do is, see, I will write C3 changes to C3 plus minus 9C2. I am planning to multiply minus 9 with the elements of C2. You check here, the elements of C2 are here. What am I planning? I'm planning to multiply minus 9 in all the elements and then add it to the elements of C3. Yes. So when I multiply minus 9, this is minus 63, minus 72, and minus 81. And why am I doing it? You will know in a while. You will know in a while. So let me now do it. So students, when I do this, I get here, see, C1 does not change. So D equals to, C1 does not change, 2, 3, 5. C2 does not change, 7, 8, 9. C3 changes. How? Minus 9 C2 and add it. So this is minus 63 added 2, minus 72 added 3, minus 81, you add it, you get 5. So now what you have, see, C1 and C3 are identical. So the value of this determinant is 0. I'll write here C1 and C3 are identical. They are identical. Very good. Okay, students, see here. The question number 3, it says, using properties of determinant, show that using properties of determinant, show that this left hand side determinant is equal to the right hand side, which is 4abc. Okay, in this question we have to use the properties, but what is important, nowhere they have said without expanding. What does it mean? It means you are free to expand. What I will do, I will start with left hand side and I'm free to expand. I'm free to expand. If I want, I can expand this. I can expand the left hand side determinant and get the value 4abc. At the same time, they have said that usage of properties also allowed. You can even use the properties. You can even use the properties. So what I will do, I understand that this I can solve very easily. So students, I have to prove LHS equal to RHS. I have to solve this and get the value 4abc. So I will start with LHS. See, in LHS, I have the determinant, and what is that? It is a plus b, a, b. Then here I have a plus c, the principal diagonal element, a plus c. This is second row, second column element. Here a and c. Then the last one you have b plus c, and so here you have c and b. Okay. See here, how do I solve? I will try to make this simpler by introducing, by achieving few zeros. So see here, how do I get some zeros? I will write here R1 changes to R1 plus minus 1 R2. You know what? The elements of R2, I am going to multiply with a negative sign, minus 1, and then add it to R1. Okay. If I do that, see what will happen. Okay. If you have questions, remember the answer to all your questions will come on its own. Have patience. Have patience. So here, see, R1 is changing, R2 and R3 not changing. So A plus C and C, then B, C, B plus C. R1 is changing. How is R1 changing? R1 plus minus 1 R2. Multiply minus here and add. So this will become B. Multiply minus here and add. Multiply minus here and add. So see, this will become minus A minus C. When you will add, you'll get minus C. And then multiply minus and add. So this will become B minus C. Got that? B minus C I get. Now what I will do is, see student, I can simply add R3 in R1, and when I do that, this will become 0. This will become 0. Actually, when I started, I had an intention to make 0 here, That is also possible. How you can get 0 here? How can you get 0 here? By multiplying negative sign in R3 and then adding. So B minus B would be 0. But then I notice that I can make 0 here. So see, the next step I write is, in the next step I write R3, I'm sorry, R1 changes to R1 changes to R1 plus R3. Now, when you do that, the value will not change. The value of the determinant will remain same. Okay, the value of the determinant will remain same. What changes is only the appearance of the determinant. So see here, is R2 changing? No. A plus C and C. Is R3 changing? No. B, C, B plus C. Is R1 changing? Yes. See. How is R1 changing? R1 changes to R1 plus R3. Add R3 here. So this is 2B and this will become 0 and this will become 2B. This will also become 2B. Okay, now see students, I am getting one more idea. I'm getting one more idea. What is that idea? I can get 0 here also. I can get 0 here also. How? See here. Because I got 2B here, if I multiply in the elements of C3, if I multiply minus 1, what will happen? This will become negative 2B, negative C, and negative B, negative C, and then add it to C1. This will become 0. Students, if you are thinking that why am I going after zeros, see, the reason is if I have zeros, the expansion of the determinant will become easier. Okay. The more number of zeros I have, the better it is for, the better and easier it is for expansion. So I will write here, C1 changes to C1 plus minus 1 C3. C1 changes to C1 plus minus 1 C3. So here see what I get. What do I get? See, C1 is going to change, not C2 and C3. So C2 I'll write as it is 0, A plus C and C. C3 I will write as it is 2B, C, B plus C. C1 is going to change. C1 is gonna change. How? You'll multiply negative and add it. So see, when you multiply negative with the elements of C3, each one of these will become negative. So how is that gonna change? It's gonna be negative C2B negative. So this is 0. This will become A minus C. And when you subtract, what will happen? See here. This is B plus C. So this will become minus B minus C. When you add, you get minus C. Okay. This is what it is getting me. Students, now my greed of zeros is increasing. Okay, I'm getting more greedy for zeros. You know what? I am getting one more 0 here. See, I can get even 0 here. How? See, I can just add the element of C2 in C3. If I add, this will also become 0. The greed of zeros are increasing. Okay, it is not a bad idea to satiate your greed if you are doing everything correct mathematically. So I write here C1 changes to C1 plus C2. There is no harm in getting more number of zeros, but just make sure that it's correct mathematically. So is C2 changing? No. 0, A plus C and C. Is C3 changing? No. 2B, 2B, C and B plus C. How is C1 changing? How is C1 changing? C1 plus C2. C1 plus C2, just add. 0 added to 0, 0. A plus C added to A minus C, 2A. C cancels and this is 0. Okay. Can I get anywhere else zeros? Can I get zeros elsewhere? No. No. You can get, but then for that you will have to, you can get, still you can get, but for that you will have to write 2 more steps. I think this much is enough. I think this much is enough. Now I expand, my dear students. So see here. When I expand, see what do I get? You know, how do you expand? We always expand along the first row. Along the first row, we expand. Now we will get this evaluated. So see, we will evaluate this along the first row. So 0 into we write the minor of 0. 0 into minor of 0. But you know, students, 0 into anything is 0. So you don't have to write anything there, just 0. Then minus of 0. Minus of 0 into what? See, the minor of this 0. You know, again, minor of this 0 is a 2 by 2 determinant, which is 2AC and 0B plus C. But again, students, you all know that 0 into anything is 0. So this is also 0 plus 2B. And then finally, we will write the minor of 2B. Minor of 2B. Got that? Yes, sir. So what will it be? See, the minor of 2B is a 2 by 2 determinant. Minor of 2B is a 2 by 2 determinant. And what is it? It is 2A, A plus C, 0 and C. So you will get 0 minus 0 is 0, just forget it. Plus 0 plus anything is that thing. 2B, and inside the bracket you will get 2A into C minus 0 into this. So 2AC minus 0 into anything is 0. So you got 2B multiplied by 2AC, that is 4ABC. What are you getting? 4ABC, which is RHS. I hope it's clear to you all. Please copy this fast.